Hello YouTube, this is Alexander again, and today is kind of reverse engineering day because I want to try to understand how this kind of lambda sensor, oxygen sensor works, because I have some trouble with the A1 Audi TDI, and it has some checking issue when the engine is cold. And sometimes it comes from the wastegate, but in this case you can probably think it can be coming from the lambda sensor. This lambda sensor has 100k life scale kilometers, and after this you need to change it to have a better result. And as you can see, this one is planar probe, because there is another kind of lambda sensor which works differently, because there is a binary on-off sensor, but this one is planar and linear. Planar because they use the same, the perpendicular way to detect oxygen on the collector. This one is a little bit damaged because I had just to make a hole to clean it perfectly, and I had to close it with some arc welding, but this is not a real problem. This is just melted metal. So in this case, you have to check your connectors. This one is 6 connector model, but actually there is only 5 wire used, and there is a trap. Actually, this wire, which is white here, is not connected on the pin in the same way, which is logic, but this is absolutely not the case. This white wire is not connected directly to this pin. It's going in this little box here, and after going through this little box, it's connected to the opposite pin. I'm trying to okay, if you can see the pins. Okay, the one left on the left side, one right on the bottom, on the up side, on the top at the left, is connected to the wire via this little connector. Actually, you have this configuration here. So, as I mentioned it earlier, you have on this kind of probe, because there is many probe like that, you have the heating element. Heating element is the yellow and blue, which you can find here. Yellow and blue. And this heating sensor is about between 3 ohm and 16 ohm, okay? And directly in the bottom of those pin, you have the oxygen sensor. This oxygen sensor is varying according the oxygen on your gas. According the heating of the element, this sensor has provided a different voltage, okay? And of course, on this way, you have the pumping current. Pumping current is a way to interferate with the crystal inside the sensor to change the voltage of sensor oxygen to correspond to the half of 1 volt. You can make different control here, and the first one is, of course, to check the heating element, which is the yellow and blue. Okay, little bit of metal like that. And so, as I tell you, the blue and yellow. As you can see, there is a very low resistor here, and according to the information you can find, it corresponds to the heating element. Okay. And now what I'm going to do is to connect. I want to connect the abilities to the pumping current to go through the cell, because to have a good working of it, you need to be sure to have a current going through the cell. So the current is going here, according to the fact that this is not the position of this white wire, because it goes on this little box. And as you can see on the schematic, you will have this resistor, and you can find it on this little box here. Let me show you. I didn't expect that, but okay. You can see rubber against moisture and other stuff. Let me remove this thing. Okay. And see, you can see this white board. This is the ceramic boards. Okay. Okay. Let's see this. This is a ceramic resistor, because the polarization need a resistor like that, which we can assume that there is simply a 12 volt coming from the battery of the vehicle going through this pin, and the polarization, the current polarization is limited by this resistor. And we can see this value. Okay, now you can see the value, about 470. Okay, so we need to put this ceramic component on this place. Okay, so sometimes you can have to check this resistor, because if it's broken or corroded, you will have a problem to polarize your lambda sensor with pumping current. Pumping current are used to compare the oxygen value about voltage, and the computer of the car change this current pumping to have always a half a volt coming from this lambda sensor. And with computing with those numbers, he understands that he needs to give more or less fuel of the cylinder. Okay, so let's check the current pumping with a very simple area, very simple device. Sorry. So we will test with this thing. So the negative of the pumping current is the negative of the sensor, oxygen sensor. So this is this pin and this pin, and the positive will be this one. Okay, let me inject some voltage on it and see if there is any current consumption. Okay, and you will have nothing. And if I reverse the current, because this device is reversing the current, this is a jet tester, but with 8 voltage, and trying to inject this 8 voltage on the pumping current to see if there is any current. And when you push, there is absolutely nothing. So there is something bad on this heating element, because you need to have some current going through this loop. And okay, now we know that there is a problem on this loop, and because we are testing this loop with included, this resistor included, and we know that the car is not able to change anything, so the computer of the car is not able to understand any information coming from this probe. So now we are going to test if there is any voltage coming from the oxygen sensor. And for oxygen sensor, we are going to use this one, this pin, and this pin. This pin is as the positive. Okay. As you can see, the oxygen sensor is working, but the pumping sensor is not working. So this lambda sensor is half good and half bad. So it was Alexander again. Hope you like this video. See you soon.